welcome everyone to this presentation. I'm going to be talking to you about, as you can see here, the title. It's a little bit cryptic, as all titles tend to be, but I do find it descriptive. It's hierarchical infrastructure description for your system management needs. And essentially, we're talking about configuration management from the system administration perspective. These are the tools that some of you may have seen, and these are the tools that I am interfacing with. Sort of listed a little bit in chronological order here. However, as a disclaimer, I do have to say that I'm going to just ignore 3 of them. As a matter of fact, the project currently ignores 3 of them. We'll get to that later. And if I'm absolutely correct about things, even though my project started when I was using Puppet, I'm not actually doing Puppet at the moment anymore. So let's just look at Salt and Ansible. We're not actually going to be looking at Salt and Ansible, but if you are using those, you can start using my tool, which I'm about to present immediately. If you're using any of the gray ones up there, then we can probably set you up with an adapter within half an hour, I'd say, and you're good to go. I just haven't done it yet. So there are 2 approaches to system automation, to system management. One of them, and that seems to be the one of these days, cloud provisioning is everywhere, and everyone seems to be doing it, and nobody seems to know what exactly it is. And there's also system administration, which is a more traditional approach to it. I think that the main difference between those 2 is that with system administration, you actually still give loving host names to your machines, whereas everything else is www001 and so on. There's also another difference between the 2 that I sort of pick up when I interact with the communities, and that is the differentiation between targeting of nodes and classifying them. Now, with all the modern tools, what you seem to be doing is targeting. You have this rack out there. You can also call it cloud if you want, but we'll stay with rack for now. And you have the task of providing mail servers. So then you say, let me target the role of mail servers at all of the hosts that are in this subnet. Or for instance, let me target the role of being a Debian node at all of the nodes that have a certain fact called Debian. Or maybe, I want the role to be hosted in Zurich to be targeted at all of the nodes that end, or the FQDN ends with Zurich, with corporation. Now I think this is backwards. Maybe it's just to me backwards, maybe it is to you too. Here's the reason. First of all, I don't think that configuration management should in any way be reactive. You should not be asking your node whether it's a Debian node and then say, okay, then you get the Debian role. I think you should actually be telling the Debian node that it is a Debian node and configure it accordingly. Because if it isn't a Debian node and you think it is, then you have another different problem. Also at this point in time, I would just quickly like to point out another dichotomy here, configuration management versus monitoring. Many of you who are dealing with the cloud have seen the web interfaces that provide sort of everything there. You can configure provision and at the same time get some sort of monitoring out of it. I want to separate them because they are separate. If you're managing, it is nice to get some sort of feedback that what you're doing is correct, but please don't use that as your monitoring solution, so please approach monitoring separately. But that was more on the side note. Let's have a look at what I mean when I say first the opposite of targeting nodes is the classification of nodes. I don't think I'm going to be speaking rocket science to any of you here, and especially those who have interacted with CFengine will know what this is all about. All I'm saying now is instead of targeting my mail server role at certain machines that fulfill criteria that are hosted in the cloud somewhere, I have this node called blue, and I am going to classify it as being a mail server, as being an NTP client, and as being hosted in Zurich. No rocket science. When you're dealing with system configuration, and when you're dealing with these automation tools, as I mentioned previously, Salt, Puppet, Chef, etc., then parameterization becomes key. You want to make sure that actually you're doing your configuration, your code in such a way that it applies to all infrastructures, ideally, and parameterize all of the changing parts that are specific to your infrastructure into a set of parameters and stay abstract in that way. And here's just a quick example. For an NTP client, you might want to define a default server, pool.ntp.org, but all the machines hosted in Zurich should get the Swiss subclass of that. And then once you have that, it's pretty logical that if you have another host called White, it's also an NTP client, but hosted in Munich, then it should get the German subpart. Now, Many of you have seen Puppet. Those of you who haven't, I'm sure you can follow this example here. You might want to do it like this. You might want to say Blue, the host that we were talking about, has an NTP server of red.example.org, is part of the common class, and provides an NTP, has an NTP role, and should install NTP. You might actually want to factor that out into the common class because all of your nodes are going to be NTP clients. So how about we just make the node inherit the class common, and then in the common class we define a default NTP server, and include common includes common, that's great. But I'm sure Puppet can deal with that. And then have NTP here, but special case Blue, because actually you want that one to use a different NTP server. So then you try to do this, and then things blow up in Puppet because you can only ever define a variable once. So that fills me with anger, especially because inheritance is actually discouraged in Puppet, and there is no multiple inheritance, and parameterization is really cumbersome. But this talk is not about slaying Puppet, so let me move on. There are also improvements since 2007 when I started reclass, the project that I'm talking to you about. But by that time, reclass had already been written, and it was written according to the Unix philosophy. So reclass actually doesn't only work with Puppet. Well, it doesn't work with Puppet at the moment, as I said, but it could. But it allows you to work with multiple tools at the same time. Salt and Ansible are pretty good examples because one of them does configuration management and the other one does remote execution really well. If you can use both of them and know that you're still talking to the same infrastructure, to the same inventory that you have in your rack or in your cloud somewhere, then I think you can sleep better at night. So reclass, mentioned it 2 to 3 times now in this talk without telling you actually what it means. Well, that is originally what it meant, recursive external node classifier, where external node classifier is a concept that comes to us from these system automation tools. I called it recursive because I was so proud that I got to implement something using recursion. And actually, it's a complete misnomer because you shouldn't call your tools according to their implementation, but you should call them according to the user experience. And really, I should have been calling it something like hierarchical or maybe Hira. But when I realized that, unfortunately, that name had been taken. So it stays with reclass, and reclass is all about parameterization. You parameterize your automation system, which is, as I said, key to system automation. You please avoid special casing anything in your code, in your actual Puppet classes or in your actual Salt states. You then define your data in exactly one place only, and you let reclass take over from there and merge it. Before I go into merging, let me just quickly tell you a little bit about this hierarchical or about this recursive aspect. We're talking about nodes and we're talking about classes, obviously, because we're tagging nodes with classes. These can specify parent classes. And it doesn't take much of a CS degree or mathematics to know that once you have parents, you have trees, and once you have trees, you have hierarchies. Once we have this hierarchy, and you will see one in just a minute, reclass then does what I call I need to show off that I did do CS at some point in time, smart deep merging on a return from a recursive descent walk. There are different storage backends that you could use. At the moment, there's only one provided, and it's YAML FS. And basically, here's what it looks like. Blue, we've met this node before, has a number of applications. Whatever applications may mean depends on the context that you're using it in. So for instance, in Salt, it would be states, in Puppet, it will be applications or actually packages that you install, and so on. And you define parameters here, and we are meeting again the default NTP server defined here. So for Blue, basically I would instruct any tool here to install the application NTP and to use pool.ntp.org as a default. By the way, I'm going to be walking through this at a reasonable pace, not too slow, not too fast. If you are bored and you really want me to skip over these basics, throw your water bottles at me and I'll know. But I didn't want to go too fast and then ask people to have to ask me to slow down because nobody would ever do that. YAML, as I already said, very easy to use and supported by all the main editors. And also here, with reclass, we can do this refactoring that we have seen earlier with Puppet. So I can take all of that stuff that I was doing for NTP, applications and parameters, and move it into the common class, because it's common to all of my nodes, and then simply make the blue node inherit the common class. And the result is the second. Now, if I wanted to override the NTP server for that specific node, I would just add a parameter to this node definition, and reclass would now give preference to the Australian subclass, subgroup of the pool.ntp.org. Yeah?
Does it mean that you are only supporting one parameter?
No. The question was whether I'm only supporting one parameter. No, I'm not. There are lists and dictionaries as well. And if I understood your question correctly, I think we're going to get to that in a slide in just a bit. So let me just build it up a little bit more. Here's the sort of most important concept. And once you wrap your head around that, I think you'll understand reclass, and probably most of you already know this. Whatever you define in a more specific class gets to override whatever you specify in a less specific class. So all of my nodes that inherit from common, where common is a very not specific class, have a default NTP server, but the definition of one specific node is very specific and therefore gets to override. There's multiple inheritance, and it's actually encouraged to use because it is in well-defined order. And I'm going to give you an example now, and I hope that's going to clear up your question and also put a little bit of this theory that I was just giving more into practice. So SSH has the setting permit root login, and we all have it defined to no, right? Some of us are using backup clients or backup solutions that require the server to reach out to the client using SSH, and in that case, you do need root access, or you need some sudo thing. Anyway, in this example, we're going to be overriding commit root login in case for all the nodes that are also backup clients. So here's what's happening. Blue is an SSH server, and therefore, as the default, it defines permit root login to no in the class for SSH servers. So far, so good, I hope. And we're going to be adding the backup client to that. And the backup client simply, normally this is namespace, by the way. I would have SSH in front of this, but somehow I left it out. But it's correct anyway. Blue now also inherits from the class backup client, and that means that the parameter permit root login would now actually be set to without password. Why? Well, because the order is well defined of the multiple inheritance. Backup client comes after SSH server, so this would actually prevail and replace the no during the merging of the parameters. Now, what would happen if you actually, as the administrator, screwed that up and accidentally put backup client before SSH server? In fact, yes, now permit root login would be no, and you would not have any backups anymore. The way to solve this is to define a dependency in the backup client on SSH server. After all, if your backup client does require SSH servers to be installed, you should be doing that anyway. So this is graphically what's happening. Blue inherits from SSH server, which sets the permit root login parameter to no. And then it inherits from backup client, which sets the permit root login parameter to without password. And I've highlighted that here in yellow to make sure that, to point out that that's actually going to be the final value. So let's swap the two. Blue goes to backup client, inherits from that, which returns with without password as the value for the parameter. Then, because SSH server is now the second one, goes out to SSH server, inherits from that, which comes back with a value of no for the parameter, and again in yellow here to suggest that that is going to be the final value, not what we want. So now we simply inherit the SSH server class from the backup client class, which means that the SSH server will set the default of no on the return from the recursive descent block of the string. Backup client will override that with the value of without password. It's highlighted in yellow here because this is the final value, because by the time we now get to the second SSH, the second inheritance here, the SSH server here, reclass will say, I've already processed this class. I won't go there again. There's more stuff you can do, and essentially the example I was giving to you is pretty simple. You'll be surprised how often you're going to end up using something like that, and you'll be surprised how often you end up putting your parameters all over the place. So remember how we earlier on had nodes that we put into Zurich and Munich and wanted to have specific settings for the NTP server? Well, there's not really any reason why I shouldn't also factor out location and then define all of my app servers and NTP servers and all of the other inventory information that I might want to keep associated with these machines into yet another class. And that's what I did here. So we have a common class, which includes the NTP class. If you remember from earlier slides, this is also a mail server, which is irrelevant for now. And then we have this new class introduced here called hosted at Zurich. And the class hosted at Zurich defines the parameter to be the NTP server to be the Swiss pool, the ntp.org project, and as you will gather from the previous presentation from the recursive descent, we're going to set the default NTP server in the common class here, and then we're going to override it in the hosted at Zurich class there, because it comes later and it's also more specific. So to return to your questions about types of parameters that are supported, essentially this tool is written in Python. Python and YAML are very closely related, and those two mainly have three types of values or variables that you can use, and lists are one of them. I started out writing reclass with a sort of policy approach that you could choose whether lists should be replaced or whether they should actually be appended. And after years actually of using it, I found out that as a matter of fact that was complete over-design. And there are hardly ever any cases where you would replace a list. And all of the times when you're doing parameter merging and configuration management like this, you want to be appending lists. So nowadays, reclass actually only lets you append to lists. If you want to have replacing of lists, then you need to just revert to comma-separated values in a scalar or whatever. Dictionaries are deeply merged. With that, I mean that what you see here, if there's a dictionary and a sub-dictionary, and the sub-dictionary defines a couple of pairs, then those pairs will get merged into a new sub-dictionary that then has all of these values. And only if, for instance, this second sub-dictionary would also define a value of blue or a key of blue, then that would override the one over here.
When you say override, do you mean override all of the values or just the one that's actually...
Just that one.
Just the one.
Just the one. And as a matter of fact, the only replacements that are ever happening are in scalar contexts. So when we have a dictionary, we actually walk that dictionary until we get to the leaves, and those leaves are scalars. And in the scalar context, we replace the new one into the old one, because the new one either comes later in the lists of classes from which we inherit, or comes further up later in the return from the recursive descent. Or what is also supported in reclass nowadays is parameter interpolation. You can, should have made this a little bit more explicit here, you can actually use variables. They are treated as scalars at this point in time as well. So in this case, base would be overwritten by a variable reference and stored into the scalar2 key. And then when we get out of the recursive descent, after we have actually processed the entire tree, then we do parameter interpolation, and that allows you to do things such as not only looking downwards into your tree, but referencing somewhere down there in your class hierarchy a value that you actually do want to define on a per node basis. So in this case, for instance, my nodes all get a greeting in the message of the day that is some sort of Pink Floyd reference, and Diamond obviously gets a Shine On message in there, and my message of the day class references this parameter, which then after all of the merging has been done is going to be replaced by what I defined for this host. or actually the most specific definition of this parameter. And what this allows you to do is to have in-dictionary references, which Python and YAML and so on, they all can't do that. And it is obviously protected against all forms of infinite loops and galactic black holes and all that other stuff.
Question?
Yeah.
2 questions. Do you have default and mandatory parameters support?
No. I don't know what you mean by default parameters, to be honest.
Let's say, for example, you wanted to define a default message in the message parameter if they didn't supply one in their node definition.
Yeah. Okay. And then, or require that all of the classes that inherit from message of the day actually define their own message. Is that what you mean by mandatory?
Yeah.
No, there's none of that at the moment, and I don't think it's necessarily a good idea to do that simply because what you do in reclass is completely up to yourself. And I understand that you might want the tool to actually help you. It will, because the output is going to be well defined, and you might see not what you want there. And I'm working on a logging framework at the moment that tells you where a value comes from, so that you can pinpoint pretty exactly why that is there and not what you expect. But in the style of LDAP and all of that, like actually mandatory parameters, I have not yet added to it, and I have not yet seen the need to do it in all these years that I've been using reclass. However, I'm open to the idea, and if the problem is a little bit how do you actually code that into YAML or all the other storage backends. You know, how do you? It's a little hard to do because you wouldn't want every parameter to have to be mandatory.
That's right. Nor would you want everybody to have to supply a default for a parameter if they don't want to. My other question was brief. It is simply the case of, is there a way to make a parameter final, which means that no subclass can override, no subsequent class can override it? Let's say you had a security policy class which determines that you're not allowed to have the root login parameter for SSH set to anything other than no. Is there a way to prevent that being overridden by a backup client class later on?
No, that's a very good suggestion. I like it.
How do I make feature requests? Because I'm happy to do that offline. How do I make feature requests?
Okay, I'll get to that on the last slide. It has all the URLs, and yeah, that's a very good idea. Again, it's going to be difficult to express that in syntax, but I'm open to this idea, and I think that you could probably do it. I already have some sort of idea.
Thanks.
So we'll have a look. We can talk about it afterwards. There was another question over there.
I was just going to say, if the variable is actually missing, what does it do? Does it actually just not do whatever it's going to do at the end, or is it actually just it disappears? Does it use blank, or does it completely delete the line?
It uses blank. And also to follow up on your question earlier on about default values, the data that are coming from reclass then actually get fed into your system. And there you might actually have your default or your security policy. It's one way to do it. You could implement it like that. But obviously this is something that many of the tools are also doing parameter interpolation, for instance, but I thought it was actually important to be able to do this in a unified level, so I moved it up into reclass. And what you're suggesting are actually two very good ideas that I think could be moved into reclass. So thank you very much for that. Any other questions at this point in time? Then I'll move on. I don't have very much left, and then I have a demo if you guys want. I just wanted to now complete the picture. I mean, you know what the merging is and how it happens, and you kind of know what role reclass takes in your system automation setup and what the goals were that I was trying to solve. Now, how do you actually plug it into what you're using? And the way that I've realized this is through adapters, obviously. So the adapters actually bridge between reclass and your configuration management or automation system, and obviously do input and output. At the moment, YAML and JSON are supplied, which is what most of the tools use these days. So, but that's easily extensible. Again, it's just one module in Python that needs to be added. As I said, yeah, Puppet is actually not yet re-implemented. It exists in the old code base. I'll get to that in just a second. I do have Salt and Ansible in the main tree already, and I'm happy to talk about with any of you about other tools. Here's a bit of history on these adapters. I don't want to bore you too much with that, but I did write reclass for Puppet because I was very frustrated with the variable situation in Puppet. I did then get very frustrated with Puppet, and then I ended up rewriting reclass and adding all these adapters. And then I have not actually bothered to rewrite a Python adapter because I'm now a Ruby free work environment. And if you are interested in this, then please come and talk to me. Salt, obviously, works just the same. Top and pillar data, those are exactly the same as for Puppet. They just name them differently. There's actually the adapter is included in Salt proper since 0.16, which means that for Salt it gets loaded as a module, which is a little bit more performant than, for instance, for Puppet and Ansible, to which I'll get in a second. There are a couple of interesting features that could have happened, but which haven't been implemented in Salt yet. So a lot of the stuff that is coming out of reclass is actually incentivizing the Salt developers, and hopefully they're going to add external interfaces for node groups to allow you to even better manage your infrastructure. And by that I mean allow you to talk to subgroups only at once. You might not actually want to roll out an update to all of the machines at all times, but just a few test machines, for instance. Same for Ansible. Here it is implemented as an external script, so slightly more overhead on the call, and it doesn't actually support all of the new features of Ansible yet because I have been moving away from Ansible and more towards Salt. And then there's Chef, BCFG2, and CFengine, which I've mentioned in the beginning. All of these have the concept of external node classification, so they could all use reclass. It's just a matter of writing the adapters. I have not looked into that. They are trivial. They are 20 lines of code, and all you have to do is basically specify how it's supposed to be invoked and how the output is supposed to look like, and maybe massage it a little bit into place, and that's it. All done in Python, so trivial to write. Here are some of the things that I'm working on and I'm planning to do. So far there's no logging framework. I got by without logging frameworks for 6.5 years, and it's getting a little bit tiresome. There's this concept of membership lists that I actually realized I promised in the abstract of this LCA talk that would be working, but I didn't get it to work in time for this talk. Let me just quickly give you an idea of what I'm talking about. Take the situation that you might have Nagios, a Nagios server, Munin server, or whatever, maybe a mail relay. And obviously you need to tell the server, the Munin or Nagios server or the mail relay, which nodes it should be interacting with. And once you've done that, you also kind of need to tell the nodes that they should be expecting to be queried by Nagios or by Munin, or should be expected to send their mail to this mail relay over there. And because reclass is all about reducing duplication, you can already see, I think, where I'm coming from. I don't really want to be telling this node that this server over there can talk to it, and tell this server that it should talk to this node. I really would like to tell this node that it is to be managed or monitored by this server over there, and that by itself results in this server over there getting a roster or membership list of the nodes that it should worry about, that it then can pass on to the system automation tool and create, for instance, the Nagios configuration files. I am trying to move it into a more long-running process, so you don't have to start it up and especially read the file system for every single request. That is currently already almost done with, in terms of memory caching, but depending on the size of the inventory, that might not be an option. Disk caching is possible. That's something to be worked on. Other data sources, potentially interesting, LDAP, databases, could be done. I haven't really looked into it yet because I find YAML very easy to maintain and to have an overview, sort of, because I'm a command line person, but I realize that other people think differently. Tests, this horrible thing called tests, and there are actually a couple of tests in place in reclass, and they actively prevent me from adding functionality because I'm like, and if I break things, then I have to touch these tests again. But I realize that's a losing battle. There's a list on the website, you'll get the URL in just a second, of further to-dos, and obviously as I already received 2 ideas here, I'd be very looking forward to more ideas from you. That's it from me. Here are all the links that I mentioned earlier, even with a QR code. And if you have any questions that we hadn't asked already, I'd love to hear them now. And if you're interested, then of course I can go to the command line interface and just sort of take your suggestions, how we modify the inventory and see what happens.
Well, that's our questions. Let's thank Martin again for the talk. Next, we've got 15 minutes.
Quite a lot of time. Another question? Yeah.
When you started this, how deeply had you looked into the capabilities Salt provides? Because as you went through, I was mentally checkboxing against the features that are in there, and I see almost complete overlap except for sort of semantic differences that might make it better for certain jobs. So I'm just wondering how much you knew when you started it, because you said you moved into using Salt as sort of your choice tool between those two that are supported. Yeah, was it actually something you knew when you started, that there was that much overlap?
The question was whether, or how much of Salt I had looked at before I started doing reclass. The answer to that is Salt didn't exist when I started doing reclass. And I do agree with you in parts that a lot of this seems to be provided in Salt, but if you do try to stick to a paradigm by which you don't duplicate any data and don't special case your code, you will have problems in Salt. It doesn't work because of all this targeting your configuration at nodes rather than classifying nodes. I realize that there are questions that are easier to be asked when you have the one perspective versus questions that are easier to be asked when you have the other perspective, but I tend to think of myself as someone who wants to be in control of the inventory, so I come from an inventory-centric perspective, and when you want to do that, then neither Salt, nor Ansible, nor Puppet can actually do these things. I don't know why. It seems very clear to me that this is the best way to do things.
So you have looked at the grains targeting where you can provide custom grains per machine?
Yes, yes, and this is, I would file this under the, I don't actually want to go out and ask the machine how it would like to be configured.
Yeah, okay, yeah.
The grains, I can install the grains for use by other tools, but not make
You
my...
want it to come from the top down regardless of what...
Top down is a very good term, yeah. Okay, well I'll just quickly go over here to the command line, and I'm sure there's going to be other questions. So we're going to meet our host Blue again, and I hope that everybody can read this, right? This is big enough. So I actually put it into an environment. There is environment support. I didn't mention that, and people use that for all various other kinds of separation between their nodes. I don't generally use it. I don't generally need it, but for the purpose of demonstration, of course, we'll put it into the LCA 2014 environment. And then you see the classes that we already talked about, right? So common class. Let's look at what the common class is like. Here it defines the applications, NTP, and also the message of the day, application, and the default parameters for the two. And if I now go ahead and run this, I'm going to close that up here, and I ask it, for instance, why don't you give me the information about this host blue.example.org. Very good. Yeah, I did move that directory around, I'm sorry. There we go. So N is simply node info. I'm calling the reclass CLI, which is more like debugging CLI here, because it has nothing to do with the tools that you're interfacing, but I find this a very expressive output that I use often to debug my own inventory. I get a couple of metadata included here, and then you see basically the merged data. So because we inherit the common class, which you see down here, we have the applications NTP and message of the day, and actually the classes are listed here as well, and the environment, and then the parameters, which is the result of the descent walk. So what you find here, because we are hosted in Zurich, is actually the Swiss pool, and you will see that the greeting, which previously was Floyd reference, a variable reference, is now replaced by the node-specific silly example that I'm giving, but I guess that's the easy way to do it here. If I wasn't working from the CLI, but I wanted to look at how Salt gets these data or how Ansible gets these data, then I'd simply call the CLI version of the adapter. So reclass minus Salt, for instance, would let me get the pillar information. That's what Salt calls the parameters, the host parameters, for blue.example.org. And it almost looks exactly the same, except the parameters are now in the top level of the output and not under the parameters header. That's simply because Salt expects them like that, and the adapter doesn't do anything other than massage these data into place. The same thing exists for Ansible, of course, which doesn't take pillar, but uses host. I wish they had a standard, but they don't. And Ansible expects JSON, so here you go. Same data, output quite differently, but the content is the same. There is a concept that I didn't mention in my slides, I'm just remembering that, which I mention here gladly, but it is to be considered beta because I haven't found the proper syntax or configuration for it. It's called class mappings, and basically it's this sort of thing. You can say, I want all of my nodes to inherit the default class, for instance. And then if I run the inventory, oh yeah. It's a list because I want to maintain the ordering of the class mappings, obviously. It didn't work.
Don't think you saved the file.
No, I did, but no, I love them. Oh yeah, no, that's perfectly okay. I'm sorry, that was an expected result. It is, look at this nice error message up here. And I simply turned on debugging mode so that I get a trace back after the nice error message. So yeah, of course, if I tell every node to inherit from the class default and then I don't define the class default, I should get an error, right? There we go. And now what you can see here is that obviously the classes is extended, the prepended actually. So these are the defaults. The class mappings happen first. They're the least specific of all of them. So you can override whatever is happening in there. But this way you can very easily, by the way, target your configuration at nodes if you want to, because there's nothing preventing me from doing stuff like, it actually takes regular expressions if you want them. There's nothing preventing me from doing something like that, except for like whack escaping requirements that are currently in place because this is YAML, and that is being dually and triple parsed and all of that kind of stuff. As I said, the class mappings is a beta feature that is in there because some people wanted it, but I'm not very happy with putting this sort of inventory-specific configuration into the main configuration file where I define where reclass should be looking for the configuration files. So there's potentially some other ideas that are floating about, but I haven't gotten anywhere there yet. So let me take this out again, and let's return quickly to the CLI. And well, what I just did was this inventory, reclass minus I. So rather than asking it for specific information about a node, I ask it about the inventory, which is the list of all of the nodes and many of the, obviously all of the tools, if they want to iterate all of your nodes, are going to be needing to access the inventory. So what you see here is basically an output that separates the inventory into all kinds of lookup indexes. So you can say what nodes define the MOTD application, and then you get a list here, and what nodes have the hosted at Zurich class, and you can define, you can find blue.example in here as well. And then of course you also get the parameters for all of the nodes, just as you would for node info. We can make this as complex as we want. I believe we have about 5 minutes left. Do you have any sort of ideas that come to you from your regular work where you'd say, is this possible to do in reclass at the moment?
What environments are you talking about that you're manually, yeah, what have you worked with?
I've worked in testing environments, of course, where there is not actually machines, but because of reclass testing and performance and so on, I've had up to 5,000 nodes defined. And it is that the reason why there's disk caching and memory caching in there is because it doesn't scale that well. Suddenly you have 5,000 YAML files, or you somehow like concatenated them all into class mappings and assigned specific classes to them, yet it doesn't scale. That's very clear. I personally use it in situations where I have up to about 300 or 350 nodes, and there I don't, it takes maybe 0.2 seconds to run reclass, and that happens sometime during the startup of the minion, salt minion or whatever, and I mean, I come from Puppet. That's an improvement. So no, but I realized that that performance is a problem, and I would like to address that and make it scalable.
For me, it was just the defining the inheritance of it for a completely heterogeneous system that's of that order of size was just I gave up, and so.
Well, yeah, it's a good point. It's a lot of work that you put in, and I ended up doing that for MadDog.net, which is 230 users and about 25 machines. And I actually went and parameterized pretty much everything. I mean, it's actually a little bit OCD there, but then again, that was my project, and I wanted to do it. And I spent a lot of time on it, and you could say that was wasted time until the point where I got so fed up with Puppet that I ditched it, and I could take the next tool, Ansible, and I wrote the adapter, plugged it in, and could try Ansible on my inventory, which had all of the parameters right there. So I didn't actually have to deal with anything ever again in terms of defining what I have. I could concentrate entirely on the tool and put that to use in a real-world environment if I wanted. MadDog.net is non-profit and not real-world. I don't give any SLAs and so on. So I can actually use it for a testing environment, and that's the reason why I run it. But once you can move between tools, and once you can use multiple tools on the same data set, suddenly that one data set becomes a little bit more important so that you actually end up putting more time into it. And the configuration, unless you go OCD like I did, if you actually focus on the important stuff, it's not going to take you that long to write that hierarchy. And it's YAML. It's really easy to do. Quickly done. Yep.
Wasn't really sure as you were writing it, because some of the examples were different to the files you've just been editing. Is the actual structure on disk to store all that data intended to be folders of small files, or is it actually more likely that you'd bunch up a few things in a number of files to take care of things like common classes and things like that?
That's a good question. I have my inventory at the moment, because this is YAML FS, stored on the file system. So I basically have two directories. Nodes already supports the notion of subdirectories, but not in such a way that there's namespacing, because it's not really like hard-coded, but a node definition should be called by its FQDN, which is unique. And but I can still use subdirectories and put them in there. And for instance, if I did that here and I moved that into the virt subdirectory, then I ran reclass again, then it would actually say, look, this is blue.example.org, but the node definition is in the virt subdirectory. This is also on the to-do list for classes, so that you can actually namespace your classes.
About concatenating those, so if you wanted multiple hosts in the same file, because their only difference is name, and you need to define the name, rather than having 20 single two-line files, you have one file that just has the same thing 20 times in it.
Doable.
So
Yeah, I would use class mappings for that. That's sort of the idea. I mean, I assume that those 20 nodes are going to have something in common in the FQDN. They might not, right? But that's sort of the point of class mappings. But there are one of the solutions for class mappings, for instance, is to define one node and then define an alias as key in there of all the other nodes that it applies to. I don't find it very transparent, but that's one way of doing it. So I hope that answers that question. Any other questions? I think we're...
No, I think that's it for the time. Thank you very much. Can we please thank
Thank you.
And on behalf of the organisation and the people here, please
Cheers.
Speaker's gift. The next